Okay, so today we'll discuss the sixth unit. Okay, sixth unit concepts, instruction level, parallelism. So in the last class, we discussed about the pipeline hazard concepts and all. Okay, we discussed about the pipeline techniques. Okay, pipeline technique, then comparison with the sequential execution, sequential how the instruction executes one by one. And in the pipelining there are some hazards or the problems will occur, hazards or the problems. Okay, the problems that comes under the pipelining. Okay, I hope my screen is visible. Okay, so there are mainly there are three types of hazard, that is a data hazard, then instruction hazards, or control hazard, instruction or control hazard, then data hazard, instruction hazard, and structural hazard. So these are the different type of hazards. So in the sixth unit we will discuss how we can overcome the data overcome the hazards overcome the hazards. Okay, so hazard means there is a delay in the execution of an instruction, delay in execution of the instructions. Okay, delay in the execution of instructions. So how we can improve? Okay, how we can improve the execution of instructions? Okay, delay in the execution of instruction. So as in the we discussed, like the sequential execution of instruction, sequential execution of instruction, it takes more time. Okay, if you compare with the pipeline instruction, in a pipeline means it is overlapped operation. So in a particular time it handles the multiple instruction execution at the same time. Okay, at the same time it handles the multiple execution, right? So the potential overlap among the instruction execution is called as instruction level parallelism. Okay, instruction level parallelism. The overlap among the instruction execution is called as instruction level parallelism, ILP, instruction level parallelism. So that where the instructions are executed in a parallelly. Okay, as we discussed in the last class, suppose these are the instructions, time t1, t2, t3, t4, t5. So here the first instruction will execute, and during the clock cycle, first instruction in the second stage. Okay, so here the first instruction in the second stage, and at the same time the instruction I2 is also fetched. So similar to that in clock cycle 3. Okay, so here the instruction I2 and here the instruction I3. So likewise in this particular clock cycle 3, all three instructions are, means all the three tasks. Okay, the I1, I2, I3 at different stages. Okay, means at this particular time it is performing a overlapped operation. overlapped operation. Okay. So the potential that overlap among the instruction execution so is called as instruction level parallelism, and the instructions are executed parallelly. So here all the three instructions, instruction 1, instruction 2 and instruction 3 with this particular clock cycle, okay, in this particular clock cycle all the three instructions are executed parallelly. So there are mainly two approaches to exploit the instruction level parallelism. There are two approaches to exploit the instruction level parallelism, ILP, that is hardware based approach and software based approach. Okay. Okay. So how we can how we can handle the instruction level parallelism. So there are two approaches to exploit instruction level parallelism, that is hardware based and software based. In hardware based approach, an approach relies on the hardware to help discover and exploit the parallelism dynamically. The Intel Pentium series, which has dominated in the market, that uses this approach. Okay. So this hardware based approach, okay, that help to, and it exploits the parallelism dynamically. Since the Intel processor that uses this hardware based concepts. Then software based approach relies on software technology to find the parallelism statically at the compile time. And this approach has limited use in the scientific or application specific environment. So the performance of pipelined processor is given by the pipeline cycle per clock cycle per instruction is equal to the ideal pipeline plus the stalls that occur at different stages. Okay, means normally suppose like this particular instruction, if it is taking one clock cycle, okay, if it is taking one clock cycle normally, all the stages taking the one clock cycle normally, okay, one clock cycle normally, and if there are some hazard occurs like structural stall, data hazard stall or control, okay, so that addition it gives the pipeline. It may be like zero also there, if okay, there may be hazard, there may not be hazard, okay. So but in the real time, in the instruction execution, there will be more hazard or the problem during the execution of the instructions. So by reducing each of the terms on the right hand side, it is possible to minimize the overall pipeline. We'll see some of the concepts. Okay. So the simplest and most common way to increase the instruction level parallelism is to exploit the parallelism among the iterations of a loop. So each iteration of a loop can overlap with any other iteration. We'll see some of the examples. Okay. So like these are some of the concepts we already covered. Okay, like what is throughput. Okay, so the pipeline, okay, I think it is visible. The pipeline that mainly the pipeline technique that mainly it helps to improve the throughput. Okay, so computers that execute billions of instructions, so instruction throughput is what matters. Okay, the time taken for the execution, of instruction, okay, the time taken for instruction execution is same, but here it improves the throughput performance, it improves. So this particular parallelism concept, the concept is designed during the 1985, since 1985, to enhance the processing speed. So that is pipelining technique, and so as you know, the pipelining means it executes the instructions in a overlapped manner, and it takes the advantage of temporal parallelism that exists among the actions needed to execute the instruction. So how it performs, like divide the instruction execution across several stages. Okay, it divide the instruction. Suppose if there is one instruction, okay, if there is one instruction, so how it divides? That divides the instruction into like instruction fetch, instruction decode, then execution, then write back, write the result. So likewise it divides the instruction into different stages, several stages. Each stage accesses only a subset of the CPU resources. Different instructions. The different instructions are in different stages simultaneously. So ideally, a new instruction can be issued in every cycle. A new instruction is issued in means a new instruction is executed. New instruction is executed in every cycle. In every cycle. So cycle time is determined by the stage. Longest stage where the cycle time means the maximum time it is taking. So this is the diagram how in the examination you have to represent the pipelining. This is called as a 5-stage pipeline diagram. Okay, 5-stage pipeline, 5-stage pipeline. So here this is the instruction fetch stage where instructions are fetched, and to fetching the instructions, okay, so it is having a register, that is the instruction register, then a memory unit, then adder circuit, then program counter that specify the address of next instruction to be fetched. Okay, program counter that specifies the address of next instruction to be fetched. Means this instruction fetch actually in the in we discussed only with a very general diagram. Okay, very general type of diagrams we discussed. PDF. Okay, so here we discussed about very general diagrams like instruction fetch, uh, instruction fetch, instruction decode, then execute, then execute के बाद क्या होता है execution, then write the result. Okay, so likewise generally we represent it, right? We are not mentioned any what actually this instruction fetch contains. Okay, we just mentioned like this generally. Okay, so here like this particular stage, okay, like it is instruction fetch, instruction decode, and instruction fetch, like there are 3 stages are there. So this type of diagrams we represented, right? But this is the how means in the examination you have to write. Okay, this particular instruction fetch, this contains the circuits, like memory unit is there, adder circuit is there. Okay, Then instruction register is there to store the instructions, and program counter. Then instruction decode and register fetch. So this particular stage, it contains the register file. Okay, this contains the different types of registers, different types of registers. Okay, then execution stage, where it performs the execution. Like execution means like some arithmetic logic circuits, arithmetic logic circuits. Okay, then mux circuit, you can see here mux, and here you can see to check the condition, to check the condition and all. Okay, so instruction fetch, decode, execution, and also the memory access. Okay, memory access means here it is like it contains the data memory, means it stores the data. Okay, it stores the data. Okay, like this particular instruction fetch, it contains means it's a collection of instructions. What if there are 100 instructions are there, so like it fetches the instructions one by one, so it is a collection of instructions. And here this particular memory access, this is one of the stage, memory access, where it loads the memory. Okay, it loads the memory in a, like means data memory, it loads the data in a memory, so that is called as a data memory. Like for example, like suppose A contains like 4, B register contains 3, so like it maintains the data. Okay, memory access. And write back, it is also one of the stage where it write the result, write the final result in a particular stage. Okay, so here like you can see the circuit diagram, how the data path and all. Okay, you can just focus on the data path also. Okay, so here in detail they are written, because to overcome the hazards, okay, to overcome the hazards, you need to understand what actually the stages and all, and how we're performing the operation and all. Okay, so there are 5 stages are there: instruction fetching, instruction decode, or instruction decode and register fetch, means it contains the number of registers. Okay, source register, destination registers and all. Okay, and also it performs the decoding operation, means suppose we add instruction hai, so add instruction means kya karta hai, it performs the addition of some like R1 register, R2 register. Okay, store the result in destination register. But actually here it won't perform any operation, it just decode it. ऑपरेशन यहाँ होता है, ये एलयू जो अर्थमेटिक एडिशन सब्सट्रैक्शन जो भी ऑपरेशन यहाँ होता है ये स्टेज में, हियर इट ओनली डिकोड, मीन्स व्हाट वी नीड टू परफॉर्म, ऑपरेशन क्या करना है, सो दैट ओनली डिसाइड्स हियर, ओनली डिकोडिंग. Okay, only it decodes, it won't perform any. In execution stage it performs. And in the memory access, so here like it access, like suppose here you can see the direction, ये जो direction है देखो. Okay, like here it is accessing some like data from the memory address. Okay, and also here it is providing the data. Okay, it is providing the data to the like a write result. So just keep in mind, data memory and instruction memory both are different. Instruction memory means it contains only the instructions, and data memory, so it handles only the data, like source operand, destination operand, the data. Okay, and write back. So this is the 5-stage pipeline. So here all the ALU operations, okay, all the ALU operations are performed on a register operand. ALU means like the execution stage. Okay, execution stage is there, no? In the execution stage, okay, execution stage. So in the execution stage, that performs in a on register operands here, the ALU operation here, this particular. So all the ALU means addition, subtraction, or right shift, left shift, some arithmetic operations that performed on the register operands. Okay, register operands. Register operands means it may be source operand, destination operand, and all. Separate the instruction on data memory. Okay, it separates the, like to store the instruction memory is separate and data memory is separate. Only instructions which access the memory are load and store instructions. Okay, like some of the instructions are there, load operation, store operation. So these instructions that access the memory means like it here load instruction, store instruction. Okay, like I think in 8085 LDA address, LDA 9000 means load data in a mentioned address. Okay, similar to store the content of accumulator to this particular address. Store address, no, store content of accumulator. Okay, here load A. Okay, here load A register from the address. Here store the content of accumulator register to address. Okay, both are opposite operation, load, but ये जो operation होता है load store, it is performing operation with memory, means accessing the data from the memory. ये जो operation हो रहा है, okay, load the data to memory. Okay, load data to memory, store data from the memory, like so. The instruction can be broken into these 5 parts, like one is instruction fetch from instruction memory, instruction fetch from instruction memory. Instruction memory means this contains the number of instructions. Okay, then instruction fetch के बाद क्या है, instruction decode and operand read, instruction decode and operand read. Then third is instruction execution stage. Then fourth is load or store operands, data memory. Okay, load or store operands means uh, it is dealing the like the data access from data store to memory or data access from the memory. Then write back result in the register. Write the results in the register. Like suppose if you have performed any operation, like addition R1, R2, R3. So these are the source operands, and this is destination operand. Okay, so source 1 plus source 2 result in destination. तो यहाँ 5 प्लस 6 कितना हो 11. तो ये 11 किस में जाना चाहिए? इट इज इन द R1 रजिस्टर. So R1 register should contain the data, means it loads, okay, in particular register, write back the result in the register. So the ALU operation, arithmetic logic operation that involves, okay, arithmetic logical operation that involves only the registers, arithmetic logic unit, ALU operation that involves the registers, okay, and here the 5-stage pipeline, it is divided into the instruction memory and data memory. Instruction and data memory. The memory is divided into two units, like instruction memory. Instruction memory means क्या होता है? सिर्फ memory instructions रहते हैं. Data memory means it contains the data. Okay, so the pipeline registers, okay, it is represented in a different way. So here like this is the instruction memory, okay, and here where instruction fetch, instruction decode. Okay, so between these two there is a latch circuit. There is a, like in pipeline there is a latch circuit between the two stages. Okay, so here IFID means this is instruction fetch stage, this is instruction decode stage, so here IFID. Then this is the ALU, okay, that is execution stage. So here you can see here ID/EC, instruction decode and execution stage. So between that this is a latch, temporary latch register. Then execution unit and the memory unit, data memory. Okay, so here EX/memory, then memory and write back, memory and write back registers, right? So here you can see this is the for instruction I1, and here this is for instruction I2, similar to for I3, and here similarly it is for the I4. Okay, so every stage that reads input and writes the output to the pipeline register. It reads the input and writes the output to pipeline registers. Here pipeline registers. Okay, because this type of diagram you are required to understand, otherwise it is very difficult to understand how we can, like, we need to find the solution, how we can overcome the hazards, right? So here like adding the pipeline registers means, like the latch circuit. Okay, so here this is the instruction fetch stage, then here instruction decode stage, that is second stage. So between that there is a latch, there is a latch circuit is added here. Okay, instruction fetch and instruction decode, there is a latch is added, means the same diagram here, there is one diagram, so this diagram is there, no, same diagram, but here the latch is not there between the instruction fetch and instruction decode, there is no latch here. So the same diagram is represented here, the same diagram, like in instruction decode and execution unit. So there is a latch circuit. Okay, then execution and write, execution, this particular memory stage. Okay, so here the execution and this particular memory stage, execution and memory stage. So there is a latch. So this is very important, this latch or this register. Okay, okay, between the stages. So this is the execution stage and this is the data memory stage. Means the hardware is designed in such a way that it contains the instruction memory, it contains the decoding and register files, execution, data memory, and write registers. Right, registers. So these are the different stages. Okay. So in the pipeline, the data path, the same diagram. Okay, the same diagram is represented in this way. Okay, like instruction memory, register files, ALU operation, data memory, and write the registers. Okay. Okay. So, but this part is there. No, it is very important. That is the latch. Okay. So this instruction between the two stages, there is a latch. Okay, this is the okay. So this particular stage is there. No, it is very important to overcome the hazards in pipeline. Okay, so between the stages there is a there is a latch or buffer registers. Okay, so what is this latch? Latch to carry the information from one stage to another. Okay, so here from stage this stage S1 to S2, the information transfer from S1 to S2 through this particular latch. Okay, S1 to S2 stage, the information will process from S1 to S2 through this which this is one latch. Okay, through this latch register. Okay, this one, and here from this S2 to S3 through this particular latch. Okay, so this is the latch. Okay. So basic idea. So the each instructions that spends one clock cycle in each of the five execution stages, and during the one clock cycle the pipeline can process five different instructions. So here you can observe each instructions, like instruction 1, which is the instruction I. Generally they are represented here. Instruction I plus 1, instruction I plus 2, instruction I plus 3, instruction I plus 4. There are 5 instructions are there, and with respect to the clock, so here during the clock cycle 1, instruction 1 is fetched. During the clock cycle 2, instruction 1 is in the decoding stage. At the same time, the instruction I plus 1 means if we take I is equal to 1, then this is a 1, 2, 3, 4, 5. Okay, so instruction I2 is, so here I can write here I1, I2, this is I3, I4 and I5, total 5 instructions. So during the clock cycle 3, the instruction 1 is in execution stage, I2 in decoding, I3 is in instruction. So here in this particular 5-stage pipeline, here you can observe at the 5-stage pipeline means it takes 5 stages, 5 clock cycle to execute one instruction, as you know. the formula Tn is equal to what is that, the number of 5 stages. Okay, the number of stages means here there are 5 stages, means for first instruction it takes 5 clock cycle plus for remaining n minus 1. Okay, that is k plus n minus 1 into t, k plus n minus 1 into t, that is a speed up. Okay, so the instruction I4 I5, then after the once this particular ones 5 stages are completed, then in every cycle, like in 6th cycle instruction I2 is executed, in 7th clock cycle I3 instruction is executed, in 8th clock cycle, next 4th cycle, then every clock cycle a new instruction is executed. Okay, so this is the same, the alternative visualization of whatever here that we discussed, the same visualization is represented here. Alternative visualization, here you can see like I mean, suppose you consider it as I1. Okay, so in the cycle 1 it is in the instruction fetch stage, and in cycle 2, so cycle 2 means it is the instruction decode and read. Here what is the second stage? Second stage is instruction decode and register fetch. Okay, instruction decode and register fetch. So here you can see this operation. This means during the clock cycle means like here we represent like this. Okay, we represent like this. Okay, so these are the same thing. Okay, the instruction execution is represented in this way. Okay, so what we do, we'll discuss the concept in the next class. Okay, because you need to understand that particular operation, otherwise it is very difficult to understand how we can overcome the hazards. Okay, so the main thing is how we need to learn how we can overcome the hazards, overcome the data hazard, instruction hazard and all. Okay.